Hi guys, this is the second video of Thanksgiving homework, so let's take a look. We finished 5.1, and so now we're looking at 5.2. What are the actual probability rules? So you can see there's a lot of vocab words that kind of go into this, and we did a couple of activities that helped us pull together some understandings of the meanings of these words. So if you look here, probability model consists of the probability fits between 0 and 1, right? The sample space adds up to 1. The probability of A is merely the number of outcomes in event A over the whole sample space. Our complement rule is 1 minus the probability of A. And A and B are mutually exclusive if the probability of A and B is merely equal to the probability of A or B, because when you subtract off this is actually 0. So nothing is there, so therefore it would just go away. And we talked about that in our notes. Okay, so now using that understanding, and I actually copied and pasted our notes, so it's just like I should be referring to these notes. You don't have to copy these down here again. Let's take a look. So it says, consider drawing a card from a shuffled fair deck, 52 playing cards. How many possible outcomes are there in the sample set? So there's 52 possible outcomes, right? And then what is the probability of each outcome? So if there's 52 possible outcomes, then each outcome is equal to that. Okay. So what would be an example? So maybe, if you're having trouble picturing what I'm talking about, let's say there's only one Queen of Hearts in this deck. Okay, so if there's only one Queen of Hearts, then there's only 1 out of 52. So the probability of getting a Queen of Hearts is 1 in 52, and that's essentially what they're saying. So now it says, define the following events. A card drawn is an ace. A card drawn is a heart. Okay, each of those are specific events. Find the probability of A. So some students know this information. Other students might have to look it up. But there should be, and actually it's important to note, they do assume on the AP test that you know and understand a standard deck of cards, that you know and understand there's 52 cards in a deck, and that you know and understand there's 4 suits. So when I find the probability of A, I have to know some background information. I have to know that the card drawn is an ace, and in a typical deck, it's the number of, we said the probability of A is the number of outcomes in event A over the number of outcomes in S. So essentially what we're saying here is that has to be, there has to be 4 aces in a deck, in a standard deck of cards, and there's 52 cards in a deck. So they're just trying to get you to establish the basic concept of probabilities. And like we did in class, it doesn't matter to me, but I mean, you might want to practice leaving it as a fraction, leaving it as a decimal, leaving it as a percent. Okay, any of those is fine. So what is the probability of, I'm going to go ahead and do the complement, and then we'll go back and do this probability of B. So what is B? So the probability of not A would just be all the times I'm not going to get A. So that is 1 minus the probability of A, but we can also just use logic, right? There's 52 cards in a deck, and 4 of them are aces. So that would mean that 48 of them are not aces. And so this would be the probability of not an ace out of a total of the 52 cards in a deck. 48 are not an ace, and 52 total cards in a deck. Right? So this makes sense, and we can list this as a decimal, and we can list this as a percent if we so choose. All right, so we can't forget, though, probability of B. So what would be the probability of B? Kind of basing this on the same thing. How many hearts are there in a deck? Well, there's a total of 4 suits. So 52 divided by 4 means there's a total of 4 suits in a deck, right? And so that means there's 13 hearts in any standard deck out of a total of 52 cards in the deck. So that would be equal to this fraction, which would be equal to this decimal, which would be equal to this percent. Okay. So now, are the events A and B mutually exclusive? And so normally we said events are mutually exclusive if you can't have A and B at the same time. But we know that there's actually such a thing as an ace of hearts. So you can't go into this same script answering mutually exclusive. You actually have to do something different this time. You actually have to say, no, they're not mutually exclusive because event A and event B can happen at the same time. An example of this is an ace of hearts. So how would we be able to see this? We would actually be able to see that by actually checking mathematically. So we could use this formula to verify this as well if we wanted to know mathematically. So if we looked at the probability of A or B is going to be equal to the probability of A plus the probability of B, and this will in fact be 0 if they are mutually exclusive. So the probability of A and B. So we know this is not the case because this is the 0.077. This is 0.25, right? And that's totaling up to more. So this would have to equal, this would have to be equal to something. And we actually know that it would be, there's 1 in 52 that is both, that you have in fact a ace and a heart because it's the ace of hearts, okay? So we know that in fact this is not true, so therefore we're good to go. All right, so now let's look at the next section, and I kind of pasted these same notes from our banana activity, and also we use these in the evil eyebrow, so let's take a look. It says, now, using a two-way table or Venn diagram, we can find out, using the same formula and or symbols, right, we can see what happens when events do overlap. So considering now that we know that these overlap, let's make a two-way table to display the sample space. Okay, so if we display the sample space, we know that there's 52 cards in the deck, right? We also know that this is event A and not event A, okay? So A is an ace. Well, we know that there's 4 aces in the deck, right? And then that would be 48 that are not aces in the deck. And as far as event B, we know that there are 13 hearts in the deck, which means that we have to know that there are not... there are 39 non-hearts. So that would be a spade, a club, a diamond, right? So now kind of using this, we actually know that there is only one card in the deck that's both, right? That's both an ace and a heart. So that one is, there's only one ace of hearts. All right, now using the complement rule, we can fill in the other information in the table, right? This would have to be a 3, and this would have to be a 12, right? And then this would have to be a 36. And here we go. We have created a two-way table that is, in fact, the sample space. Now they've asked us to use a Venn diagram to do the same thing. So I'm going to make a Venn diagram. So this one will represent being an ace, right? And this one will represent being a heart. Okay. And we know we have one ace of heart, right? That's in the middle. We know this part goes here. And we know, looking at our notes, right, this here, that number goes there. So that number, this number 3 goes here. And this looks really good to us right now because we know that in our circle, there's 4 aces total in the deck. Now, kind of using our notes, we see this number here, and they put it there. So we can kind of think the same thing. This number 12 needs to go here. And this makes us feel good because we know there's a total of 13, 12 and 1, a total of 13 hearts in the deck. So what does that leave us with? That leaves us with 39 that just are neither ace nor heart, 39. And there you have it. We have the Venn diagram of the sample space. Now it's asking us to find the union of A and B. All right, so we look at this notation and we notice in comparison, as we look at here and here, that this symbol, the upside down, is actually the word or. And it's a way of shortcutting the word or. So I think of it like this. If I was in a boat, here I am, hopefully I'm sitting down, and I'm using an oar, right? There I am using oars. And so I think it's not spelled the same, but that's how I remember that means or. Okay. So now we started this before on the last page and we didn't finish it. So the probability of A or B, and we could write it in either notation type, A or B, is going to be equal to the probability of A plus the probability of B minus the probability of A and B. Okay, so we know that the probability of A, right, is 4 over 52. We know that the probability of B is 13 over 52. And we know that the probability of both is 1 over 52. So we don't want to accidentally count those twice. So what we have here is like 13, 14, 15, 16, 17. Take away 1. So that would be 16 over 52. Okay? And we can show this as a fraction, as we've done there. We can show it as a decimal, or we can show it as a percent. Nice work, guys. Check out the next video for more in the packet, section 5.3.